Okay, so this is where we picked up or left off last time. So we're going to pick up here. And so we're looking at some definitions. And so we are here with the state function. And this is a pretty weird definition. And so I'm going to write it out, then I'll explain it for you. So the state function, it does not depend. So it does not depend on the path, and we'll talk about paths here in a minute, on the path. So path is important and does not depend on the path taken to reach a value. And I'm going to write it up here so I don't run out of space. Taken to reach a specific value. Okay, what the heck does that mean? Okay, so we're going to be finding things like delta H. So delta H is the amount of heat given off. You can find delta H a lot of different ways. And so we're going to use different equations to find it. So we'll use like Hess's law, and we'll use calorimeter equations. And so we'll use multiple different ways to find the same answer. So what a state function is it's saying that there are multiple ways to come up with the same value. And so a lot of times when we look at these answers, they'll vary slightly, like plus or minus a few a few kilojoules, things like that. But the general idea is the same: is that we can find something like heat given off, delta H, in multiple ways. Okay, now for a state function, the 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 things that we're going to do here are all basically different ways to solve for the same thing. So, not that that comes up, but you will find that we're going to do a lot of problem solving, and at the end of the day, it's all kind of similar. So, okay, what the heck is delta H? Keep talking about delta H, and delta H, obviously, the H is the heat in the system, and so delta H, if you're in physics, the delta is change. So when you see like a triangle like this, so that's going to equal change. So the change in heat. And so delta H is going to be the difference or the change in heat content. All right. And so once again, that H value is going to come up over and over and over again. And most of what you're solving in this entire unit is H values. Okay. So it says difference in heat content. And then here's another vocabulary term that we need to kind of look at. So right here, enthalpy. Not a very good looking highlighter, so use this one. So enthalpy. And so with these IB vocabulary pieces, you do not want to get confused with things such as terms. And so you're going to have enthalpy. And so that is going to be used also with delta H. And so these are going to be solving things the same exact way. So just don't get confused on the vocabulary. I think a lot of times students get a problem wrong because they don't understand the vocabulary. So it says, hey, find enthalpy or change in enthalpy. And they're like, well, I don't know how to do that. Well, you do, because they're just asking for delta H. So a lot of this stuff is pretty specific, but as long as you have your arsenal of vocabulary terms, you're going to be successful. So, okay, so you've got a couple of diagrams here, and they're just going over the concept of endo or exothermic. And so I do think that if you logically think about it, if you're holding an item and that item is hot, like it's burning your hands, well, it's giving off heat and you're feeling that. And so that should make sense that exothermic things are giving off heat, where endothermic thing would be if you hold something and it's cold because it's pulling the energy in from the surroundings, including your hands, and you would feel cold there. So it says a new vocabulary term here: enthalpy level or energy diagrams. And so these right here, these are energy diagrams. And so energy diagrams are pretty easy to look at. And so if you look at a diagram here, you've got the over here on the y-axis. This is your heat value, high or low, and this is time. So basically, on this first one, we started at a high heat level and we ended at a low heat level. So what happened? Well, it got rid of heat. If it gets rid of heat, if the heat is coming out of the system, like we have right here, if the heat is coming out of the system like this, then you're going to grab this thing and it's going to feel warm. So when the heat's coming out, why is it coming out? Well, it's usually coming out because it's more stable. And so this piece right here, this arrow, this is your delta H. So the delta H, so like, is this value. So let's say that this was 50. And let's say that this was 10. So if we went from 50 down to 10, it would have given off 40 kilojoules of heat. So a lot of times there's values here, and we can measure that. And the delta H is the difference, like how much heat did it kick out. All right. So the one below it, it's just the opposite. So this is the one you would grab and it would be cold. And your hands would get cold because, see, it's pulling the energy into the system. And so everything around the system is going to be cold. So, well, look at this. At the beginning, we're low. And at the end, we're high. So same, let's give it the same numbers. Maybe it was 10 here and 50 here, except for we went up. So this would be plus 40, or this one would be minus 40. So that's the idea. And so a minus exothermic, a plus endothermic. So that's kind of some background there. Okay, so let's zoom out again. Let's fill in these notes real quick. So you want to know this term. So you really should make a note that this term, energy or enthalpy diagram, you do want to know that because sometimes on the test they have you draw one of these, which is really easy. They only have two shapes. They have in or out, energy in or energy out. So energy out, exothermic, energy in. But you do want to know the pattern. Basically, the pattern is always like if I start with a big value and end with a low value, that's exothermic. And then the opposite, I start low and I end high. That's endothermic. So those are kind of the patterns to look for. Okay, so let's look at the definition here. It says the top energy or enthalpy level diagram shows a blank reaction. And so we want to write in there kind of a small space here. So let me see if I can blow this up again. Give me a little more space to write. So that is going to be exothermic. So it doesn't look like it's going to help me any. So we'll just go ahead and do our best. So this is going to be exothermic. And it says reactants have more energy than products. And then right here, delta H is going to be negative. You need to memorize that. Like you need to know exothermic and negative go hand in hand. And then the bottom, it's going to be the opposite. So endothermic, and then there's a big problem with all of this chemistry stuff is that they use a name that's almost identical, endo versus exo. Just have to memorize it. But the endothermic means that the heat's getting sucked in, and the delta H is going to be positive. So like I said, if you don't know this and this, we're going to have problems later on. You really need to know those ideas for a test, because if you don't understand that negative is exothermic, then we are going to have significant problems later on, because that's going to be something that we're going to assume that you know, right? So we're going to assume that you know that, and so that's going to be a problem if you don't. So, okay, endoexothermic, pluses and minuses. All right, so now we're going to do, starting to do a little bit of math. Okay, I just kind of looked at my time here. This one's we're about 10 minutes. So I think I'm going to go ahead and pause it here, and then we'll pick up with this on the next slide, giving us a full amount of time.